So over here we have the request for the general solution of 3 sine of x being equal to 2 times tan of x. So the first idea I can think of is just to expand on the fundamental identity we have over there on the right hand side. So we'll have 3 sine of x being equal to 2 times sine of x over cosine of x. So as long as we respect that cosine of x in this case cannot equal 0 because we're not allowed to divide by 0, let's just multiply both sides by cosine of x and see what pops out. So we'll have 3 sine of x times cosine of x, and then we'll have 2 times sine of x, which I think is sort of what we like. That's just better to deal with because we can move everything to the left or transpose everything to the left by subtracting 2 sine of x from both sides. That zeroes out as we want it to, and we'll have 3 sine of x times cosine of x minus 2 sine of x all equal to 0, which allows us to take out the common factor of sine of x. Just algebra popping its beautiful head out where we least expect it. So we're left with, well, if we divide everything by sine of x on the left, take it out as a common factor, we're left with 3 cosine of x over there minus 2, and that's all equal to 0. Now we can just deploy the zero product rule as we are used to it. So what we'll have is sine of x being equal to 0, or in this case 3 cosine of x minus 2 all equal to 0. Now in this case our reference angle x will equal 0 degrees. So let's leave that over there because we know there's another 0 that we have to deal with. And then over here we'll have, well, cosine of x being equal to 2 over 3. And I need to get that reference angle using a calculator, believe it or not. So our reference angle over here has x equal to 48,2 degrees. So let's deal with this. Well, the graphical interpretation will have us that therefore x is equal to 0 degrees plus 360 degrees times k, or x is equal to, remember, like I said, this is a graphical interpretation. So there's a 0, there's a 0. We will ignore that because the addition of the period or the periodicity takes care of that. But the second 0 sits here at 180 degrees, and then that of course is also equal to 180 plus 360 degrees plus. So that's equal to x is equal to 180 degrees plus 360 degrees times k. Now for our second set over here, our second reference angle, that'll just be x being equal to 48,2 degrees plus 360 degrees times k for the first quadrant solution. That's where cosine is positive, or x is equal to, well, 360 degrees minus 48,2 degrees plus 360 degrees times k, 11.8 plus 360 degrees times k. So in conclusion, x is equal to 0 plus 360 degrees times k, or 180 plus 360 degrees times k, or 48.2 plus 360 degrees times k, or 311.8 degrees plus 360 degrees times k. And never forget, k needs to be an element of the integer set, and that's what turns it into a general solution because we are accounting for the periodicity of the trig function.